Hello everyone, welcome back to Husky Math. In this video, we will be learning the application of derivatives in finding the errors and approximation. But before we begin, please note that this topic, that is errors and approximation, may or may not be included in your board syllabus, okay? So do check your respective syllabus first and let's get started. Question 1. Here using derivatives, we have to find the approximate value of square root of 49.5. So in order to find the approximate value of square root of 49.5, first we need to have one formula, that is, we know that the derivative of a function can be written as limit delta x tends to 0 and f of x plus delta x minus f of x whole divided by delta x. Here delta x is a small change or a small value. So here looking at this square root of 49.5, let us consider fx as square root of x, because since we have to find the value of square root. So first let us differentiate this function both sides, then we will have f dash of x and ddx of square root of x is 1 by 2 root over x. Now looking at the formula here, so let us consider x as 49 and delta x as 0.5. So if I add 49 and 0.5, we will have 49.5. Therefore, using the formula, that is f of x plus delta x minus f of x over del x equals to f dash of x. So this will be equal to, let us put the value of x as 49 here, plus 0.5 minus putting the value of x as 49 here also, and we have assumed delta x as 0.5 here in denominator, and this equals to f dash of 49. So here it will be f of 49.5 after adding minus, now since we have assumed as f of x as a square root of x, so here f of 49 means square root of 49 whole divided by 0.5 equals to, and since we have got the value of f dash of x as 1 by 2 root over x, then f dash of 49 can be written as 1 by 2 square root of 49. Therefore this implies, so now again f of 49.5 is square root of 49.5 minus, and we know that the square root of 49 is 7 whole divided by 0.5 equals to 1 by 2 into square root of 49 is 7. So now let us cross multiply, then we will have square root of 49.5, of which we have to find the value, minus 7 equals to 0.5 over 14. So this implies the square root of 49.5 equals to, so this can be written as 5 by 10 into 14 and plus 7. So that means square root of 49.5 will be equal to 5 1s are 5, 5 2s are 10, so it will be 1 by 28 plus 7, and the approximate value of 1 by 28 will be 0.03 plus 7, and hence it will be 7.03. That means the approximate value of square root of 49.5 is 7.03. So here we have to just remember this formula from the first principle of derivatives. Question 2. Find the approximate value of log of 4.04 with base 10, and the value of log 4 is given, that is 0.6021 when the base is 10, and the value of log e also given, that is 0.4343 when the base is 10. Now looking at the question, we will define a function. So let f of x equals to log of x with base 10. So let this be equation 1, and if I differentiate this, then it will be f dash of x equals to the ddx of log x is 1 by x, and since the base is 10, so here we have log of e with base 10 also, and since the value of log of e with base 10 has been given, so here we will put it here. Then it will be f dash of x equals to 0.4343 by x. So let this be equation 2. Now since we have the formula, that is f of x plus del x minus f of x whole divided by del of x equals to f dash of x. Now since there is a number 4.04, then we will break this 4.04 into two parts, that is 4 and 0.04. So here we will break this 4.04 into 4 and 0.04, so that if I add these two numbers, I will get 4.04. So I will consider this 4 as x and 0.04 as small number, that is del x. So put x equals to 4 and del x equals to 0.04 in the given equation. Then we will have f of 4 plus 0.04 minus f of x is 4 whole divided by del x is 0.04 equals to f dash of 4. So this will implies f of 4 plus 0.04 is 4.04 minus f of 4 can be written as log of 4 looking at the equation 1. So it will be log of 4 with base 10 whole divided by 0.04 equals to f dash of 4 looking at the equation 2. We can write the value of f dash of 4, that is 0.4343 by 4. So here we can cancel 4 ones are 4, 0.01. So this implies, so f of 4.04 from the equation 1 is log of 4.04 with base 10 minus, and we know the value of log of 4 with base 10 that is given in question is 0.6021, and if I cross multiply here, we will have 0.4343 into 0.01. So this implies log of 4.04 with base 10 equals to 0.6021 plus, if I multiply this two, then I'll get 0.0043, and on adding these two numbers I will have 0.6064. So this is the approximate value of log 4.04 with base 10. Question 3. The radius of a sphere shrinks from 10 cm to 9.8 cm. Find the approximate decrease in its volume. So as the radius of the sphere is decreasing, so obviously there will be the decrease in volume. So we have to find by how much the volume is decreasing approximately. So for that we have a special formula, that is the change in y can be written as dy over dx into the change in x. That means if there is a change in x, then there should be the change in y. So here if I use this formula, then here it will be the change in volume will be equal to dv by dr, where r is the radius, and whenever there is a change in radius. So here this formula tells us that if there is a change in radius, then this much will be the change in volume. So we will be using this particular formula here. So here initial radius of the sphere is 10 centimeter, and the change in radius is 10 minus 9.8. That means the radius has been decreased by 0.2 centimeter. Now the volume of the sphere is given as 4 by 3 pi r cube. So let us differentiate both sides with respect to r. Then we will have dv over dr equals to 4 by 3 pi, and ddr of r cube will be 3r square. So here 3 and 3 got cancelled. That means dv over dr will be equal to 4 pi r square. So we will find the value of dV by dr when the radius was 10 centimeter. So it will be 4 into pi into 10 square. Since 10 square is 100, so 100 fours are 400 pi. Now we will be using this particular formula, that is, what will be the change in volume when there is a change in radius. So since we have got all the values, therefore here del V will be equal to dV by dr is 400 pi into, and the change in radius is 0.2 centimeter. So here it will be 400 pi into 2 by 10. So here we will cancel this. So this equals to 80 pi. That means there will be the change of 80 pi centimeter cube in volume whenever there is a change of radius of 0.2 centimeter. Question number 4. This question is from the error part and the only question in this video. So here we will be requiring the concept of errors. So for that, let us discuss errors. If x is a true value of any physical quantity, then we will consider del x as absolute error. Then if I have the ratio of absolute error to its true value, then this error is called relative error. And if I multiply the relative error with 100, then this is called percentage error. So here we will be requiring the concept of this also. So let us read the question. The pressure P and the volume V of a gas has a relation P into V to the power 1 by 4 equals to K, where K is any constant. Then we have to find the percentage increase in the pressure and corresponding to a diminution of 0.5% in the volume. So the question has said that if there is a percentage decrease of 0.5% in the volume, then we have to find the percentage increase in the pressure. So here 0.5% is the percentage decrease in the volume. So that is del V by V into 100 is minus 0.5. See, I am writing minus since there is a decrease in the volume of 0.5%. So here we have to find the percentage increase in the pressure. That means we have to find the value of del P by P into 100. So this is the thing we have to find it here. So now let us write the equation that is given in the question. P into V to the power 1 by 4 equals to K. Now before differentiating this equation, we will operate both sides with log. Then we will have log of P into V to the power 1 by 4 equals to log of K. Using the property of log, then we will have log P plus log of V to the power 1 by 4 equals to log K. This implies log of P plus 1 by 4 log of V equals to log of K. Now we will differentiate this equation both sides with respect to P. So ddP of log P is 1 by P plus 1 by 4. ddP of log V is 1 over V into dV over dP equals to, since K is constant, so ddP of log K will also be 0. So this implies 1 by 4V into dV over dP equals to minus 1 by P, and let this be equation 1. Now we have one formula, that is the change in volume will be equal to dV by dP into the change in pressure. So from here the value of dV over dP can be written as del V over del P. So let us put this value of dV over dP in equation 1. Then we will have 1 by 4v into del v by del p equals to minus 1 by p. So let us keep v one side, that is del v by v, and minus pressure on one side. And since we have to find the percentage increase in the pressure, so we will multiply this equation both sides with 100, then we will have 1 by 4 del v by v into 100 equals to minus del p by p into 100. And we know the value of del v over v into 100 from here, that was given as minus 0.5. So let us put down there, then we will have 1 by 4 into minus 0.5 will be equal to minus del p by p into 100. So here minus and minus got cancelled. So this implies 1 by 4 into 0.5 is 1 by 2 equals to del p by p into 100, and hence it will be 1 by 8 equals to del p by p into 100, and hence del p by p into 100 will be equal to 1 by 8 is 0.125. And since this is a percentage increase, so we will write the answer in percentage. So this was the sum application of derivatives in approximation and errors. So this much in this video. Keep learning and keep practicing.